So example number 52, evaluate the integral from limit 0 to 1 3x squared plus 5 over x minus 1 into x plus 1 squared dx. To evaluate that integral, it is integration by partial fractions, isn't it? So you have to resolve that problem into partial fractions. So here, the function we have inside here is, we have 3x squared plus 5 over x minus 1 and x plus 1 squared. So if you want to resolve this into partial fractions, the first factor here, x minus 1, is a linear factor, isn't it? So a linear factor is going to be a over x minus 1. The second factor here is a repeated linear factor, isn't it? So a repeated linear factor, we are going to have b over x plus 1, then plus c over x plus 1 squared, until you exploit its powers, isn't it? A repeated linear factor, you have to repeat it until you exploit the highest power. So the highest power of this linear factor is 2. So if the highest power of that linear factor was not there, if you just had x plus 1, meaning it was just going to be b over x plus 1. Are you seeing? When it is now x squared, it is now simple as that square. If it is cubed, until you reach the highest power of that repeated linear factor. Having done that, you simply look for the LCM. What is the LCM of these three numbers? The LCM is what you have here, okay? Which is x minus 1 into x plus 1 squared. So here we have a, x minus 1 goes here how many times? It goes x plus 1 squared times, meaning if you remove x plus 1, you remain with this, isn't it? Then plus b, x plus 1 goes here how many times? It goes x minus 1, x plus 1 times, isn't it? Because x plus 1, if you remove x plus 1 from here, you remain with x minus 1 and x plus 1, because there are two of them here, isn't it? You go to the next one, plus c, x plus 1 squared goes here how many times? If you remove x plus 1 squared, you remain with x minus 1. Are we together? So after that, this side, remember, so it is this equation which is equals to this. So if this equation is equivalent to this, the denominator is the same, so you compare the numerator, isn't it? You compare so the numerator of this we have is 3x squared plus 5 to be equals to the numerator of this, which is a into x plus 1 squared plus b into x minus 1, x plus 1, plus c into x minus 1. Are we together? Now, I want to show you the best way to solve this. Comparing coefficients may be time consuming, isn't it? If you want to compare the coefficients, may be time consuming. So the best thing you do, the value of x, you let x to be anything to get rid of certain unknowns. Like here, what can you let x to be so that you take a certain term to 0, isn't it? Like here, you can see we have x plus 1, meaning if you let x to be negative 1, you will get rid of a. Are you seeing that? So it is the x variable you are letting to be something, because a, b, and c are constants. You cannot say let a be 3, because a is a constant, you know what constant it is, isn't it? But x is a variable can be anything. Are you seeing that? So you can let x to be anything to get simultaneous equations to solve the value of a, b, and c, instead of comparing coefficients, which might result into a simultaneous equations in 3 variables, isn't it? And that is a long process. Are you seeing that? So here, if you can start by letting x to be, let x to be 1. If you let x to be 1, you'll have 1 minus 1. So that will be 0. Are you seeing that? Yes. You are checking what can you let x so that you are able to take a certain factor to 0, isn't it? So here, it means if you let x to be 1, you will have 1 minus 1, 0. So 0 times the whole of this factor will go to 0, isn't it? Then here, the whole of this factor will go to 0. So you will only remain with a. Are you seeing that? So when you let x to be 1, here will be 3 into 1. What will we have this side? See, 3 into 1 squared plus 5 to be equals to a into 1 plus 1 squared. See, x is 1. Here when x is 1, it is 1 minus 0. The whole of this goes to 0. 0 times everything goes to 0, isn't it? Here is 1 minus 1, 0. The whole of that goes to 0. So you see, when you let x to be 1, you are able to get the value of a. Are you seeing that? So that we have 3, 1 squared is 1. 3 plus 5 is 8. So this implies what? 8 is equals to 1 plus 1 is 2. 2 squared is 4. So 4 times a is 4a. So what is a? You divide both sides by 4, isn't it? So you get a is equals to. Are you seeing that? Are you seeing how this is simpler? Instead of forming simultaneous equations by comparing coefficients, isn't it? When you compare coefficients, it will be a very long process. Then the next one, you let x to be negative 1. Are you seeing? When you let x to be negative 1, see negative 1 plus 1 will go to 0. Are you seeing that? Here again, you have negative 1 plus 1 will go to 0, meaning all these terms will disappear. You will remain with only c. Are you seeing that? Are we together? Yes. You let x to be a value such that a certain factor is going to 0 to make work easier. Is that okay? So when x is negative 1, when you let x to be negative 1, what do we have? Where there is x, put negative 1. We will have negative 1 squared will be positive, isn't it? So you remain with 3 plus, which is to be equals to negative 1 plus 1, the whole of this will go to 0, isn't it? Then here, negative 1 plus 1, here will be 0, meaning the whole of this will go to 0. 0 times everything will be 0, isn't it? Are you seeing that? So long as there's 0 in any of them, then the whole thing goes to 0. Then the last one, negative 1 minus 1 goes to negative 2, isn't it? So you now remain to negative 2 times c. Negative 2, negative 2c. So from this you can see, you divide both sides of the equation by negative 2 to get the value of c, isn't it? So what is c? So you divide both sides by negative 2. Then you get c to be negative 4. You see the first equation, letting x to be 1, you are able to get the value of a alone. Second equation, letting x to be negative 1, you are able to get c alone, isn't it? So the next equation, you can let x to be anything, even if you are now not able to eliminate x anywhere. Where there is a, you will put the value of a. Where there is c, you will put the value of c, because you've already found the top, isn't it? Are we together? So it means the next, the third one, you can let x to be anything, even if it is not going to 0, because we already know the value of a and c, isn't it? So you can now let x to be 0, isn't it? You can now let x to be 0. So if you let x to be 0, what do we have? This one will be 0, this side will remain with 5, isn't it? Will remain with 5 to be equals to, this is 0, 1 squared is 1, so that is a. Here you remain with a, you remain with 5 to be equals to a, go on, here is 0, so this is now negative 1, here is 0, so this is 1, so 1 times negative 1 is in negative 1, negative 1 times b, so it is minus b, then you go on, x is 0, so you remain with negative 1, negative 1 times c, c minus c, then you substitute, so you know the value of a is 2, and so you know the value of c, negative 4, so you substitute them to get b, isn't it? You substitute them to get, is that method simpler or the other one is simpler? This one is more simpler, isn't it? So can you substitute those values? Substitute those values. So we have here is 5 is equals to a is 2 minus b, we don't know b, then minus c. C is negative 4. Are you seeing that? So negative into negative is positive, isn't it? Isn't it? Yes. So negative into negative, this one now becomes plus 4. So 2 plus 4, 6, isn't it? So here this side you will remain with, what will you have? 5 is equals to 6 minus b. Remember the sign of b is negative, isn't it? So what is b? B is 1. Because when you bring b this side, it becomes positive. When you take 5 the other side, it becomes negative. So b is 5, 6 minus 5, isn't it? Are you together? Minus b coming this side of the equation, it becomes positive b. Positive 5 going the other side, it becomes 6 minus 5, isn't it? Yeah. So B is 1. So we found the value of A, B, and C. Then we go back and we substitute them in our equation. So what have we found? Let us go back. This value of A, we found it to be 2, isn't it? This value of B, we found it to be 1. This value of C, we found it to be negative 4. Are we together there? So after that, we now want to start the integration process. Remember, you first of all start by doing it as indefinite integral, isn't it? Indefinite. So what do we do here? For us to evaluate this integral from 0 to 1, meaning we introduce integral all through, isn't it? So we introduce integral, then you put with respect to x. With respect to x. So you can see the integral which you are given can be rewritten in that form using partial fraction. Are you seeing that? So that is now integration by partial fraction. So we are still evaluating it as indefinite integral. After we've done with integration is when we come and put our limits 0 to 1 later. After we've done with the integration, okay? Are we together? So we start. This is 2 is a constant you factorize outside the bracket, isn't it? So if you factorize 2 outside the bracket, here you remain with dx over x minus 1. See, you remain with dx in the numerator over x minus 1. Here, 1 is a constant, but 1 is silent, isn't it? See here you remain with dx over x plus 1. Then here you can see negative 4 is a constant you factorize outside, isn't it? So you get negative 4 integral of dx over x plus 1. Are we together? We are still evaluating the indefinite integral. Then later we'll put the limits later after we are done with the integration process, okay? So from there we go on. So start. What do you get here? This is, you are supposed to get, if you evaluate dx over x minus 1, you are supposed to get ln of x minus. Remember what we say. What did we say? When the degree of the polynomial in the numerator is less than the one in the numerator by 1, then it is a logarithmic. Then it is resulting into a logarithmic function, isn't it? Now see how it is coming about. You let what is in this denominator x minus 1 to be u. Are you seeing that? So if you let u to be x minus 1, this is rough work. That is why we were doing standard integration is to be used. Are you seeing that? Yes. So if you let x minus 1 to be u, meaning if you differentiate u with respect to x, you get 1, isn't it? Taking dx the other side, you get du is equals to dx. Are you seeing that? So from there, you now see you are integrating dx over x minus 1. So where there is dx, put the value of dx. Dx is the same as du over x minus 1 is the same as u. So you can see if you integrate du over u, you get ln of u. So that ln of u, what is u? U was ln of x minus 1. So you can, ln of x minus 1 is what you write here. Standard integration. It is not to be done. It is something you look and write. Are you seeing that? Are you together there? You move to the next ones. So those standard integration are to be, they are to be used the way you've seen I've used it there. You just look and you see, okay? Move to the next. So just start shouting them. What is integration of dx over x plus 1? ln of x plus 1. Because if you let x plus 1 to be u, it means if you differentiate it, you'll get the u to be equal to dx. So you have the u over u. That is ln of u, isn't it? And your u is x plus 1. Are you saying it is something we're just working the brain one touch? Are we together? So in that part, when you have dx over x plus 1, you let u to be x plus 1. So if you differentiate u with respect to x, you get u over dx is 1. If you differentiate x, you get 1. You differentiate a constant, you get 0, isn't it? You take dx the other side, you get du is equals to dx. Are we together? Yes. So when we are now integrating dx over x plus 1, dx is the same as du. Where there is dx, you put du. Then x plus 1 is what? Is u. So you see you have du over u. When you integrate the u over u, you get ln of? You get ln of u, isn't it? So what is ln of u? U is x plus 1. That is ln of x plus 1. And that is exactly what we found here. Meaning these are rough work. There are things you just look and see. Okay? That is ln of x plus 1. Go to the last one. The last one was squared. This was squared. Good. Are you able to see that one? What is the answer of that last one? Huh? That last one is not ln because you can see the square outside, isn't it? Are we together? So the square outside, so it cannot be logarithmic, it cannot result into logarithmic, isn't it? Because the square outside. So what do you say? You have there dx over x plus 1 all square. What is the denominator is what you write? It is x plus 1 you learn to be. You forget about the power. Are we together? We are trying algebraic substitution. Is that okay? You see, if you see it is not resulting into an inverse function because this has nothing to do with an inverse function because there's a square outside, isn't it? So it means you go to algebraic substitution. Is that okay? So you go here. What is your u? X plus 1. You don't include that power to be part of u, no. Are we together? Meaning it is now going to be u squared. Is that okay? Are we together? So u is x plus. So if you differentiate u with respect to x, you get, differentiating x, you get 1, differentiating 1, you get 0, isn't it? You take the x to the other side, you get the u is equals to the x. So can you now start substituting? What is the x? Where there is the x, you put the value of the x. The x is the same as the u over x plus 1 is u, but it is x plus 1 squared, meaning it is u. Are you seeing you have the u over u squared? Are you seeing this is now not logarithmic? Because u is squared. It is only logarithmic when u does not have a power, isn't it? Are you seeing that? Yes. But this is now squared, meaning it is in form of the standard integration of a polynomial. Are you seeing that? Because this is written in the form what? U raised to negative 2du. When negative means it is in the numerator. That is in form of a polynomial. So how do you integrate polynomial? See, you add 1 to the power and you divide by that resultant power. That's how to integrate a polynomial. Are we together? So if you look at that, what do you see?